we were brainstorming things we could change to make it our manipulated variable. So yesterday, we came up with the following ideas. See if you have them. We could change the substances we put in the vials. We could put yeast, we could put polyacrylate crystals, we could put brine shrimp eggs, we could put radish seeds. We could change the type of liquid. We could put them in water, we could put them in salt water, we could put them in sugar water, just like the experiment we did. If you want to get creative, you can put them in different liquids. This is what we're measuring. You measure and observe the dependent variable. And yesterday we got how long they live. We can measure that. The number of living things you can count. How big they get. Remember I said with the digital microscopes, you can measure their size. And they do it in like pixels, but that's okay. That's a measurement. And how they respond to their environment. How can you do that? What can you do to check how they respond to their environment? Yeah, Ashley.
How much they weigh.
Good idea, yeah. So there are ways you can tell how they're responding. For those of you that are new, we go from brainstorming to choosing what variable we're going to work with. And yesterday somebody mentioned that we have to manipulate just one variable. Why in the world would we want to manipulate just one variable? Don't you want to learn tons of stuff? Because
you manipulate more than one variable, you don't know what's going on.
You can't make any good results. You don't know what caused your results. I'll give you an example. Let's say I changed the type of liquid and the temperature, and I did them both. And let's say my brine shrimp grew like crazy. Which one caused it?
The salt water.
You don't know because you changed two.
Exactly, and that's the whole point. You never want to manipulate two variables at once because then you don't know which one caused your change. So for me, I'm going to pretend I'm a team of one, and I'm going to choose type of liquid. I want to try different liquids. I'm going to put this one over here. I will change one manipulated variable, type of liquid. And I got to pick one from down here, right? Say right. Thank you. And I'm going to pick how long they live. I want to see how long they live in different environments. So I'm going to measure by just days that they're alive, and I'm going to have like 3 to 5 different types of liquid. We've got 5 vials, so I can do up to 5 different things. Okay? What do I do with all the rest?
You're going to keep it the same.
Exactly. Now, moving the sticky notes is the easy part. All I got to do is this. But what I'm doing is a little bit more complicated. You and your teammates have to choose how you're going to control every other variable. Now, in real life, especially in biology, it's really hard to control every single variable. That's why we bring things into a laboratory setting, because out in the world, if you're observing brine shrimp in their natural habitat, you can't control much. I mean, they're going to go anywhere they want. You're going to have all sorts of rain and pollution and things you can't control. In the classroom, can we control those things?
Yes. Yes.
Yeah, we can control. Thank you. I need your attention up here. We can control as many things as we can. That's why this list is so important. So I got to try to figure out how I'm going to control these things. So here's what I came up with. And this is an idea of how you could start typing your lab write-up. So I had to come up with a title for mine, and since I'm changing the type of liquid, I chose for a title, Different Environments Lab. Okay, that's my title. Your title could be different, unless you're going to manipulate the same variable I chose. So I wrote manipulated variable, type of liquid. Responding variable, how long they live. Have I told you who they are?
Nope.
Not yet. Not yet, but I have to. That's really important. My controlled variables. All right. Substance you use, I'm going to control that by only using brine shrimp. I'm not going to use brine shrimp and radish seeds and yeast because then I've made it too complicated. Okay? So that's how I control this one. Now, how much liquid? I put that down here. I will use the same amount of each liquid, 3/4 of a vial. That's how I've controlled this one. Let's see, the habitat or environment, that's kind of what I'm changing to, except I'm just going to keep them all at room temperature, and I'm not going to use cotton. I'm just going to fill the vial 3/4 full. Do you see what I'm doing here? I'm choosing how I want to control these variables. And I have to keep all this stuff the same for my whole experiment.
Did you guys choose one?
Yes, we did.
What are you choosing?
We chose to measure, like, as the saltiness in the water increases, we wanted to know how that affects the polyacrylate crystals.
Awesome. Ooh, that's a great one.
So what I want to, like what we want to do is
Well,
like,
whatever you want to do, because I don't have any seeds.
like grow radish seeds, and but like change like what they're growing in, you know. But
Wait,
it's
can we
not,
keep the branches somehow?
but it's not in any of the like what would it be called?
Ooh, so that's a new one you came up with. No, we could call that the environment. You're changing the environment they're growing in.
Maybe that's the 7th one I don't have.
Yeah, that could be it. Environment or habitat.
Natasha, where's mine?
Okay, so I'll just write environment.
Excellent.
Okay.
Yeah. So what are you guys manipulating?
Water and cotton.
Type of liquid.
All right. I can understand that one.
The reason I'm starting you off with these inquiry boards is so that you can have one last look at how to structure a lab, and then the next lab we do, we won't be using the boards. Once you've chosen your variables, your one manipulated variable and your one responding variable are the ones that are going to move forward. Because if you look at like the next board, ask a question, it only asks you for your changed and your responding. And this is actually pretty cool because remember this helps you write the sentence. Okay, it actually gives you a structure for writing the sentence. And this is fine to start off with, but later on we won't have it. So I usually try them both and see which one sounds better. So here's an example of how I use this inquiry board. All right, listen to this. What is the effect of the type of liquid on the... And this one says how long they live, but does that sound grammatically correct? Sounds weird, so I have to change it. I can change it to the amount of time brine shrimp live. So, I'll say it again. What is the effect of the type of liquid on the amount of time brine shrimp live? Now, check this one out. Gotta give it food, huh? So we'll have to talk about how to do that. So, what about this? How does the type of liquid affect the amount of time brine shrimp lives? Which one sounds better? A lot of times this one sounds better. I really like this one. It always ends up sounding better. So here's what I did. I wrote, if you recall, I'm really a stickler for you guys labeling each part of your lab because it makes it so much easier for me and other people to read it. So when you write problem, make it bold and underline. Bold and underline, just like these three. So there's my problem question. And I kind of highlighted the manipulated variable in a bluish color and the responding variable, I didn't have pink, so I picked something kind of reddish. So there's my question. How does the type of liquid affect how long brine shrimp live? And the problem is food is a whole different variable. So I have to make sure I give each vial what? Same amount of food. Because if I feed one more than the other, I've now manipulated two variables and I've ruined my chance at having some good results. So that's how you're going to write your problem question. choose one of these two ways to write your question, because your question, a lot of you start it with a question. That's the way science works. You come up with a question and you go, I'm going to make a lab to test it. And most people don't think lab or experiment, but most people try something to see if they can answer their question. That is science. I know. Pretty cool, huh? There's something really important that I don't want you to be limited by. If I take my manipulated variable and my responding variable and move over to my hypothesis, and I plug them in, it's not going to sound right, is it? Because as the type of liquid increases or decreases, that's not what I'm doing, right? So I got to get a little bit creative with how I write my hypothesis. Don't use increases or decreases just because that's what it tells you to do. You're going to have to change it so the sentence makes sense. So I'm going to try different types of liquid. So I can just say something as simple as the type of liquid changes, okay, the amount of time brine shrimp will live will, and I can say change, because how do I know which one's going to make it increase? That's what I got to describe here. If I think salt water is going to make them live longer than sugar water and plain water and vinegar water and oil water, that's what I want to say here. This is your hypothesis. So you want to say what you think is going to happen. And don't worry about being right or wrong. That is the last thing you should be worried about at this stage of a lab. Remember, because I say it every year, you have to explain why you think that's going to happen. Does it have to be right? Absolutely not. If you're wrong, that is so okay. Because when you get your results, that'll give you kind of a, I wonder why that happened. That's where learning takes place, folks. So here's how I did my hypothesis following this guideline. As the salt content in water increases, I could use the word increase. Brine shrimp will not live as long because too much salt in the water will kill the shrimp. Now, I don't really know this. I'm hypothesizing. That's my prediction. If I actually did the lab, which I'm kind of not because one of you is going to do it, I would learn something. That's the kind of lab I want you to do, where you literally learn something new. When you've got something that sounds good, makes sense, is going to be new for you, you're moving on to the procedure. Procedure has three parts that I'd like everybody to include: a drawing, a list of materials, and a step-by-step plan. And some of you, many of you, have done this before. So if you're doing it in your notebook, no problem, okay? Label it procedure, include your drawing, and notice I've got everything in my drawing labeled. I ask that of my science students every year. Label everything in your drawing. When you're doing the materials list,
But so how do you draw that so good?
I'm going to show you. I found a way to do it. I've been trying all sorts of things. List your materials, because that's when you and your team are going to say, all right, Mr. G has distilled water. He's going to give us the shrimp. We can bring salt. We've got the vials. We've got the vial holder. So all we really need is a measuring spoon and salt. And then your team knows what to bring. Now, if you're going to do sugar, you probably want to bring sugar, but I have salt. And then you do your steps. Really important. I've had students in the past write their steps as a paragraph. Really hard to follow. Number your steps. I say that every year. Some of you have heard me say this before. It's okay. I'll keep repeating myself. Number every single step.